Incrementing and decrementing are the two most common programming operations. For this reason, they are given special consideration in C++. By increment and decrement, we mean adding or subtracting one from a variable's value, respectively. In fact, these operations are so important that there are two versions of the increment and decrement operators. The syntax for the increment operator is 2 plus signs and 2 minus signs for the decrement operator. We can place these before the variable name for the prefix or after for the postfix operations like this. Clearly, these are all unary operators. The difference between prefix and postfix operators is somewhat subtle. Most of the time we won't be concerned about it since we will almost always use the prefix operator. However, we will explain the difference since the distinction is particularly important in legacy code and operator overloading. Now if we write a program like this, for example, it doesn't really matter whether we use a prefix or postfix operator for incrementing. Either one is functionally equivalent to this and gives the expected output. However, if we insert the increment operator into the output line, then there is a difference. In this case, the inline prefix operator outputs the numbers 1 through 5. We can read this as increment and then use the variable. The postfix operator, on the other hand, gives us the same output as before. We can read this statement as use the variable and then increment it. My personal preference is to avoid the confusion and just do my increment on a separate line of code as we did before. There is, however, a large quantity of legacy code in existence which uses the inline increment operator. So why do we have separate increment and decrement operators? The first reason comes from a time when memory was more scarce than it is now. Since these operations are so common, making them shorter saved a few bytes at each use. Likewise, inlining the increment or decrement could save a line of code. This was once important, but memory is no longer a significant issue. The second reason for these operators is optimization. It used to be that languages were tied more closely to the internal machine instructions. Internally, incrementing and decrementing is much faster than simply adding or subtracting. With modern compilers, this optimization is taken care of during compilation. So this is no longer an issue, and it's just as fast to write this or this. The third reason for the operators is simply convenience. For such common operations, making them easy to type makes sense. Finally, we may want to have optimized increment and decrement operators when we are working on our own non-native types. This introduces the idea of operator overloading, which we will cover later. As a final example, we will look at a code sample using the decrement operator in a while loop. What we said before about incrementing holds for decrementing as well. Using the prefix operator, we get this. Using the postfix operator, the value is checked before the decrement and we get this.